Hey everyone, and welcome. So, today we're going to dive into a problem that honestly is a great problem to have. Your app is a smash hit, it's gone global. But that success comes with a huge question. How on earth do you make sure every single user, no matter where they are, gets that same amazing, snappy experience? I mean, seriously? Congratulations are in order. Your app has gone viral, it's everywhere. But here's the thing. That success creates a totally new and very physical problem. It's one thing to serve your users in London when your server is right there. But what about your brand new fans in Tokyo or Sao Paulo? How do you keep things feeling instant for them? All right, let's really frame this problem. Picture this. You've built this awesome SaaS app. Your user base is just exploding all over the world. But that fantastic, lightning-fast experience your users in, say, San Francisco are getting, for someone in Frankfurt, it's a slow, frustrating crawl. So what gives? Why is that happening? It all boils down to one simple, unavoidable fact. Data doesn't teleport, right? The actual physical distance between your user and your database server, that's the ultimate speed limit. And that delay, that lag, it has a name. It's called latency. And let me tell you, latency is the absolute enemy of a great user experience. Okay, so a round trip from London to San Francisco takes about 150 milliseconds. And you might think 150 milliseconds, that's nothing. But here's the catch. Modern apps, they're not making one trip. They're making dozens, sometimes hundreds of these trips just to load a single page. And all those little delays, they add up fast. And that's the difference between an app that feels instant and one that just feels broken. So the big question is, how do we fight the laws of physics? Well, let's dig into the first and probably the most common solution out there. This approach, it's perfect for a very specific scenario, when you've got one main group of users who are creating most of the data, and then everyone else around the world is mostly just, consuming it. This solution is called geo-replication. And honestly, the best way to get your head around it is with an analogy. I want you to imagine a master kitchen. This is your main primary database. Let's say it's an Azure SQL database. This is the only place where new dishes get created. Then, that master kitchen sends all those perfectly cooked dishes out to local cafes all over the world. These cafes are your read replicas. They can serve customers super fast, but they can't cook anything new themselves. They can only serve what they're sent. So you get it, right? The key takeaway here is that all the writing, all the data creation happens in that one central place. That data then gets copied out to all the other regions so your users there can read it nice and fast. And hey, if the master kitchen has a problem, no big deal. One of the local cafes can get a promotion and become the new master. It's a really simple, really powerful, and honestly, a very cost-effective way to do things. But this leads to a pretty critical question, doesn't it? What happens when your customers in every single cafe want to start cooking their own meals, right? If every time they want to create something new, they have to send that order all the way back to the master kitchen on another continent, well, that's going to be slow. And that exact problem brings us right to our next solution. Okay, so this is where we talk about solution number 2. This is the one you need when every user, everywhere, needs a top-tier, high-performance experience for not just reading data, but for writing it too. We call this global distribution. And if the last model was the master kitchen, this one is the independent kitchens model. Now imagine this. With a database like Cosmos DB, every single city gets its own fully equipped independent master kitchen. It can create new dishes, it can serve local customers at insane speeds, and all the while it's syncing its menu and recipes with the entire global chain. Everyone gets to be a chef. So with this model, your users are always routed to their closest kitchen for everything, reading, writing, the whole deal. What does that mean? It means incredibly low latency for everyone. This kind of architecture, it's literally built from the ground up for those mission-critical, absolutely cannot go down global apps. All right, showdown time. We've got our one master kitchen model versus our many independent kitchens model. Let's put them head-to-head and see how they stack up on the metrics that really, truly matter for your app and, your business. And this really gets to the core difference in philosophy between these two. With replication, you have one single source of truth, and you just copy it everywhere. But with distribution, the idea of truth itself is decentralized. Every location has its own source of truth, all so it can serve every user locally and at top speed. Okay, now this is where the rubber really hits the road. Let's look at a few things. First, RTO.
That's just a fancy way of saying how much downtime to expect. With Azure SQL, we're talking minutes. With Cosmos DB, we're talking seconds. Then there's RPO, which basically means how much data could I lose. Again, for both it's measured in seconds, but Cosmos DB can actually get you to 0 data loss. And just look at that write latency. High for a lot of your users with SQL, but low for everyone with Cosmos DB. That's huge.
And that really brings us to the most important point of all. This isn't just some techie decision you make in a vacuum. It's a fundamental business decision. You have to ask yourself, can my business afford for our app to be down for 5 minutes? Can we afford to lose even a few seconds worth of transactions? The answer to that question, that's what's going to point you to the right technology. So, okay, with all that in mind, how do you actually decide what's right for you? Let's walk through a super simple, practical framework that can help guide you to the right choice for your app. You can really boil it all down to a simple 4-step path. We're going to start simple, figure out what you really need, scale up only when you have to, and then, last but not least, think about all the legal stuff.
All right, let's break it down. My advice? Always start with the simpler geo-replicated model. Seriously, it's the default for a reason. It works for a huge number of apps. The real trigger, the key question you have to ask, is do my users all over the world need a fast write experience? If the answer is a big yes, well then the extra performance and reliability you get from a globally distributed database like Cosmos DB is totally justified. And one last thing. If you have to guarantee that, say, a German user's data never leaves Germany for legal reasons, Cosmos DB gives you way more granular control over that kind of thing.
So I'm going to leave you with this one final thought to chew on. We're living in a world where pretty much every business is a global business now. So the real question is your data architecture ready to compete on that stage? Think about it. Thanks for watching.